Students' needs first. If somebody needs tutoring for a final, I'll be available. So, what do we got tonight? Okay. Okay. So it's a triangle. Okay. Can you describe? Oh. Okay. A rectangular prism. Okay. Like a brick. Trapezoidal prism. Okay. Trying to think of how that relates to trig. That sounds more like geometry, but. You sure it's not a triangular prism? Okay. Which is all that means is you have identical trapezoids on each end connected by the solid object. I could try to draw it here, but let's see if I do something like this. And you'd have basically the same end over there. And that corner would go there, that corner would go there, and that corner would go there. Something like that. Okay. What's the question? No, that's okay. Go ahead. Not sure what you're saying. You're talking about doing that? Okay. Which I tell you what. Have you ever sent me a picture of a problem? Have we ever gone through that? You do have my email in your camera? It'd be better if you send it to my email because the text message goes to my phone, and then I have to figure out how to get it from my phone onto my computer, which isn't that easy to do. So it's better if you send it to davidcowan1949@gmail.com. And if you've sent one before, then the moment you type in DA, it should show you a default. So you don't have to type the whole thing in. Are you using an iPhone or a Samsung? Okay, make sure you send it as an attached file, large image, not small. You could probably get away with a regular image or large image, but a small image doesn't provide enough resolution to be able to see it once it gets to my end. Does it say file sent? Because it's not going to get here until it says file sent on your end. Can't say file sending, it's got to say file sent. I'm not not quite, there it is. Yeah, I got it. Only thing is you didn't send it as an attachment. You can see my screen, right? Notice on my screen there's no image. So you've got to, the way I do it on a Samsung, I'm not exactly sure how you do it on an Apple, but on the Samsung, I pull up the image and then share it. Share it to whatever email I want to send it to. Okay. Well, let's see. No, I haven't gotten it yet. It takes a little bit longer when there's an attached file, just because there's more data to send when you send an email. So it's going to take a minute or two before it's going to say file sent. Do you have any problems? Ah, there you go. There we go. Now I got it. And you can see that we have it here. All right. No wonder that was tough to describe. Let me see if I can figure this out here. Let me have a look at it. I may have to, I'm trying to read it. Unfortunately, may have to download it and open it with Paint so that I can minimize it. I'm missing the last few words of that paragraph. Well, yeah, so we got the straw company is designing a new straw for a special edition of what? Okay. Show. Okay. 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 Well, I'm not sure I have either. First of all, I'm not sure that qualifies as a rectangular prism or a trapezoidal prism, because the trapezoidal prism would need two sides that are identical, parallel, and opposite one another. Now, are they saying the top is that? In other words, the top is 3 inches by 2 inches? All right, I think I got this figured. I think I understand what they're saying here. So the straw has to be between 65 and 80 degrees. So theta is what has to be between 65 and 80 degrees. Now, let's think about this for a moment. The straw, especially made, is 10 inches long. And does that work? So, you know what? I'm not going to be able to do this without shrinking it. So I'm going to have to download this. Takes just a second. Hold on a second. I may have done it right there. Yeah, perfect. Oops, hold on. Okay. Now I think we can get somewhere. Shrink it just a little bit more. Okay. So what they're saying is that's the same type container they use for French fries at McDonald's, the supersized fry container. Okay. The straw specifically made is 10 inches long. So let's label that. So it's 10 inches from there to there. Oh my goodness. You got to be kidding me. This is your trig problem? For a trig practice test? Well, I would have to think about this for a while to figure out. I guess we would have to figure out what the diagonal is from there to there. That's not going to be that easy to do because we're not dealing with all right angles. We're dealing with a right angle right there. I just can't tell what it's a right angle between. I guess this triangle here is a right triangle according to that right angle thing. It goes all the way to the line. So that's a right angle, but we don't know much. Wow. Yeah, this is. Are you taking a trig course, or are you just doing the trig that comes with Algebra 2? Really? Wow. This is crazy. It really is. I don't say that very often, but this is crazy. To give you this kind of a problem when you're dealing with Algebra 2. Because here's the way it goes. They give you a little bit of trig in geometry, and then they give you a little bit more in Algebra 2, and then you take trig for a whole semester. If I was dealing with a student that was taking it for the whole semester, this would be a hard problem, a really hard problem. I'm great at trig. I really am. It's my favorite thing to tutor. I know it well, and I can't even figure out what the heck's going on here. So that's why I say it's crazy to be given these kind of problems to somebody that's in Algebra 2 taking, the minimal trig. The other problem is number 2, or can I even, that's not in my camera image, right? Right. Well, I think number 2 is going to be more of a 2-dimensional problem. See, the hard part of number 1 is it's 3 dimensions for one thing. And it's very bizarre for another. I guess we could figure out this angle down there on the other half of theta by taking the tangent of 2/3, the inverse tangent of 2/3. That would give us that angle. But then where we go from there, I have no idea. he shouldn't be giving you these kind of problems. I'm sorry, but he just should not. Did you send me another picture of number 2? Number 2 looks like it's more in 2 dimensions instead of 3, which is a lot more understandable and less confusing if it's in 2 dimensions. Did you send it to me, or because I can only see that much of it? A police car with a spotlight on is parked 20 meters from a warehouse entrance. Okay. Yeah, when you get problems like this that are going to be pretty much impossible to verbalize, you should send them well in advance of our session so that we don't have to spend so much time of our session waiting on having these problems sent over the internet. It's sent now? Okay. Yeah, there it is. This time, hold on. Oh, okay, good. Yeah. Yeah, I think I can work with this. Everything we see. Okay. All right. So we have a police car with its spotlight on. It's parked 20 meters. In other words, the graph shows us everything we really kind of need to know. The angle theta gives the degrees the spotlight has turned from aiming perpendicular to the warehouse. And x is the distance along the side of the warehouse from where the entrance is located. Okay. How far can the light shine along the warehouse at an angle of 20 degrees? So here's what they're saying. If that's 20, how far is x? What's the maximum angle? So what we need is a trig function that compares 20 meters with x and 20 degrees. Oh, hold on a second. Yeah, no, here at an angle of 20 degrees, yeah. Okay? So when theta is 20 degrees, what is x? That's the question. So first of all, what trig function relates? In other words, the only angle we know of, well, we know that's 20, and we also know the other one is 70. But let's deal with that 20 degree angle. So I've got some trig function of 20 degrees, and I want it to be x over 20. What trig function relates x to 20 like that? Okay, the most important thing you can remember about trig is this. So which trig function is it? Yeah, tangent relates the opposite side over the adjacent. And the opposite side to 20 is x, and adjacent side to 20, or to is 20. So it would be the tangent of 20 degrees equals x over 20 meters. And then you can solve for x by just putting that into your calculator. Go ahead and do that and tell me what 20 times the tangent of 20 is. And it's completely coincidental that both of those are 20, which is another thing I do not like about this problem, because some students are going to think that those have to be the same numbers. They don't. It's just coincidence. So it's 20 times the tangent of 20. You have to make sure you're in degree mode, not radian mode. All right, so 7.28 meters. Now, that actually makes sense because we know that angle right there is 70 degrees, right? Right? And the length of the side opposite an angle always, in other words, the biggest angle in a triangle is going to be opposite the biggest side. The smallest angle in a triangle is going to be opposite the smallest side. So I've got a 70-degree angle opposite the 20 meters, and I've got 7.28 meters opposite the small angle of 20 degrees. So that passes my ballpark test. In other words, if we'd have come up with a number greater than 20, it would not have been, wouldn't pass the smell test. Okay? So that's the maximum distance. Well, not the maximum. If they turn their spotlight 20 degrees, they will be able to see 7.28 meters from the entrance. That's all that means. Okay? But you need trig to figure that out. They know they're 20 meters from the entrance, measured perpendicularly, but they want to know how far their spotlight covers. In other words, if there's somebody with a gun right over there, they don't see him if he's more than 7.28 meters away with their spotlight. Okay, so B says there's another entrance 100 meters away from D that the policeman would like to illuminate, but knows the light can turn up to an 80-degree angle. Explain how to know if the policeman can light up the other entrance. So, here's what we need. This is 100 meters. And the question is, can he turn that spotlight at an angle to cover 100 meters? In other words, 20 degrees only covered 7.25 meters. So what would theta have to be to cover 100 meters? Start with an equation. Whenever you're dealing with trig, you want to start with the trig equation. Again, you only have two numbers. You have 20 meters and 100 meters. So which trig function is going to be used? Adjacent and opposite. In other words, the only angle we're dealing with is that angle right there. We don't even know what that is yet, but we're going to try to figure it out. Okay? So call that angle theta. So you're relating theta, 20 meters, and 100 meters. So what's the trig function? Of what? You're always taking trig functions of angles. Always. You take inverse trig functions of numbers to determine angles. So the tangent of theta is equal to what? Yeah, 5. So theta is equal to what? Inverse tangent of 5. Here's what's going on here. We've got the tangent of some angle equals 5. So if we want to know what that angle is, we're going to take the inverse tangent of both sides. Well, if I take the inverse tangent of the left side, I get theta. But if I take the inverse tangent of the right side, what do you get? You got to plug that into your calculator. Inverse tangent of 5. So if they point their spotlight at a 78.69 degree angle, they will be able to see 100 meters. So the question says, is he can turn it up to 80 degrees. Can he light up the other entrance? Yes, he can. In other words, he can do it because he only has to turn his spotlight at a 78 degree angle. If he can turn it at an 80 degree angle, he can go cover further than 100 meters. Okay, so the answer is yes, because we figured out that for him to cover the door, theta is 78 degrees. So if he can turn it 80 degrees, he can definitely cover the door. Okay? The key thing with trig is you are either solving for sides by taking the trig function of an angle, or you're solving for angles by taking the inverse trig function of the side ratios. We solve this by taking the inverse trig, the inverse tan of 100 over 20. That tells us what theta is. So that's the most important thing to remember, is you're always taking trig functions of angles, but if you're trying to solve for angles, you're always taking inverse trig functions of numbers. All right. Is there, okay. Was that all there was on that problem, A and B? Okay. I got the same picture again. Yeah, and that's like the fourth picture I've gotten from, oh no, that's the third image that I've gotten from you. But it's got the same 2701. It's the same JP, it's the same file as the previous one. It's image 2701.jpg, which was exactly that file also, which we looked at. Is the picture you're trying to send me that same page, just problem 4 or 3, whatever? Okay, if you can verbalize it, or I was going to say, try backing up a little bit from the page so that you take the whole page with one picture. But verbalizing it is fine. Okay. Yeah. What quadrant's that going to be in? Where is the cosine positive and the sine negative? It's only one place. Okay. there's quadrant 1, 2, 3, 4. Remember this, all students take calculus. What that means is that in quadrant 1, all 6 trig functions are positive. In quadrant 2, only sine and its reciprocal, cosecant, are positive. In quadrant 3, only tangent and cotangent are positive. And in quadrant 4, only cosine is positive. So which quadrant is cosine positive and sine is negative? Not 1, because they're all positive in 1. It's not 2, because sine is positive in 2. It's not 3, because both of them are negative in 3. But notice in 4, the cosine, that's what that C means. The cosine's positive. Everything else is negative, so the sine would be negative. So we're dealing with a fourth quadrant angle. Okay? Now, when they say draw it, I'll do it the way they want you to do it, but it's not the easiest way to do it. And then I'm going to show you the easy way to do it. Okay? So we know we're in a fourth quadrant. And we know we're dealing with that angle. That is theta. It's more than 270 degrees. Okay? But when you draw that ray line, you also create what is called a reference triangle. And this angle right here that I'm labeling angle 1 is the reference angle. Now, if the cosine of theta is 3 over 7, then this has got to be 3 and this has got to be 7, right? In other words, the cosine of angle 1 would be 3 over 7. Oh, excuse me, I've labeled it wrong. I was about to explain why the sines were right there. 3 has to be there, right there. Cosine is adjacent over hypotenuse. Notice that the 3 is in the positive direction of x. And the hypotenuse is always positive on these unit circle diagrams. What you're really looking at is a polar graph. This is kind of a person's introduction to polar graphing, is the unit circle. Okay? So they want to know this point right there. What is it they're asking for? Oh, okay. Well, here, let's have a look at it. Yeah. I think I got it twice. This time, I'm going to try to download it. Whoops. Okay, hold on a second. I got to download both of these. And I have to wait for it to come up here before I can get to it. Okay, hold on. And then I got to download that one also. Okay, now I've got to find my downloads and pull up the last 2. So that one and that one. Minimize that for a moment. Should we open 2700 first, or does it matter? If I open them up with paint, I can minimize them, rotate them if I need to, so forth. Okay. So number 7, huh? You're much heavier into trig than most Algebra 2 students get. This problem that you're looking at here is a problem that a trig student taking a full semester of trig, this would be a hard problem. Okay? We can do it, but I don't know that I can explain it in 20 minutes. In other words, the sinusoid function is a very, here's what it says. A equals, or excuse me, y equals A times the sine of a b times x minus c plus d. Does that look familiar? Really? They have not taught you that, and yet they're asking you this question? You've never seen that equation before. All right. Well, let me teach it to you. What you're looking at here is sinusoidal. I didn't draw it very good here. Let me draw it a little better. Okay. And then, if you're familiar with how the ocean goes, that buoy goes up to its high point, down to its low point, back up to its high point, down to its low point. Okay? So if you were to graph it based on time, it would look something like that, where time is going in that direction. Okay? Now, they give us all of the information we need to figure out, first of all, the amplitude, which is A, is the difference between the highest point and the lowest point divided by 2. Okay? So what is that? The difference between the highest point and the lowest point is 6 feet. So the amplitude is half of that, 3. Okay, so A is 3. The period, there's no horizontal or vertical shift here, which means that C is 0 and D is 0. So really, the equation you have is this. Okay? Now, here's the key thing. The period of the movement is equal to 2 pi divided by b. Right there, 2 pi divided by b. Well, we know that the period is 15 seconds. It goes from its high point to its low point, back to its high point every 15 seconds. So 15 seconds is the period, and that's got to be equal to 2 pi over b. So if you solve that for b, you get 2 pi over 15. That's what B is. So the equation that models this movement is y equals 3 sine of 2 pi over 15 x. Right there. And like I said, that is a 2-session subject, the sinusoidal function. Y equals a sine of b times x minus c plus d. That's 2 full sessions of trig. 2 full hours to teach you that. Okay? Now, they've made this one a little simpler because they have made c 0 and they've made d 0. So we have a little bit of a simpler function. Excuse me, that should say y. But the key thing to know is this. How does b relate to the period? You know what the period means, right? The period is where you go from one point to the next point that starts the cycle all over again. So that is your period. And in this case, that distance is, 15 seconds. Usually the horizontal axis is time on these sinusoid functions. And this is y. Okay? So x is in seconds. So we know this is 15 seconds because from here to here. Because they told us that to get from its, you can measure period, you don't have to measure it between those 2 points. You could also measure it from the bottom back to the bottom. That's also going to be 15 seconds. Or you can measure it from the top to the next top. That's going to be 15 seconds. So the period merely means how long it takes to get back to the same point on the sinusoid graph. Okay, here if I start there, then the next time I get to a point, that's at the origin heading up. That's the next point. If I'm going from top to top, then I go from top to top. That measures 1 period. And they said that from its high point to its low point, returning to its high point every 15 seconds. That means from the high point to the next high point, that's 15 seconds. Okay? Now, because we know over here that the period is always 2 pi over b, well, we know the period is 15 seconds, so we can solve for b. And we did. It's 2 pi over 15. And that's the coefficient that goes in this sinusoid function. In other words, this function right there at the top left models this action perfectly. You could give me any time you want, and I can tell you where that buoy is. At time 0, sine of 0 is 0, so y has to be right there. In other words, here, let me draw it, make it a little clearer. That's time 0. Okay? The amplitude is how far you go from the middle of the curve, that horizontal line of symmetry, to the peak. That's 3. That's what the amplitude means. It goes 3 feet above the middle line. That's the middle line right there. That's 3 feet higher. And then when it goes down to all the way to there, which is 3 feet lower. So it's a total of 6 feet between the high point and the low point. Okay? And that's really all you need to know. But you could tell that if I say, where is the buoy going to be at the end of 20 seconds? So all I got to do is plug in 20 for x, and I can come up with an answer. Okay? Because that would produce a number. If I wanted to know where the buoy would be, and this is really height. Why? I'm assuming the buoy starts out right there at time 0. And at the end of 15 seconds, it's back to there. So if I wanted to know where it was at the end of 20 seconds, it's going to be somewhere up there. It's going to be on the rise. And that's how you use the sinusoid function to solve any kind of a problem, a word problem, that involves periodic motion. This buoy in the ocean is periodic motion. Does the same thing over and over and over. It goes up 3 feet, and it goes down 3 feet. And it goes up 3 feet, and it goes down 3 feet. Forever. Okay? So, write an equation that describes the motion of the buoy. We've done that. That's that equation right there. Where the high point corresponds to time 0. Now, we didn't do that. In other words, the equation that I wrote at time 0 is not the high point. It's at the midpoint. In other words, it's right there at time 0. No, excuse me. Yeah, that's my origin. In other words, if I were to draw, here, let me, hold on a second. Let me draw this a little bit better. So they want it to start at the high point. So they want it to start there, and then go down to the low point, and then come back up to the high point, and then repeat. It doesn't matter whether I go left or right. It's the same concept. Okay? The difference is that this does have a vertical shift on it. If I want it to start at the high point, then could they make it any tougher for you? I mean, this is ridiculous. This is ridiculous because it's not the way to teach trig. You don't teach trig by giving somebody a level 9 on a 10-point scale degree of difficulty. You just don't do it. It's too hard for a beginning trig student to understand it. But basically, because they're starting at the high point and going down, what function does that? It's cosine. So I can use cosine. Just because it's called a sinusoid function doesn't mean you have to use sine. You can use cosine. So if that were my function, now at time 0, notice that the cosine of 0 is 1. So it starts at 3 feet above the midpoint line. This is the midpoint line right here. Right? So if I'm drawing an XY axis here, I'm drawing the midpoint right there so that the horizontal axis goes through that. And now I know that when x is 0, or t, the horizontal scale here is t, when t is 0, well, the cosine of 0 is 1, 3 times 1 is 3. So it should be 3 feet higher than the midpoint, and it is. Now, if I were to draw this out, it would go like this all the time, okay? And because you can choose either sine or cosine, you always choose the one that has the least amount of shift. In other words, this C and D, C represents horizontal shift, D represents vertical shift. This has been vertically shifted. Let me think for a moment on this. Yeah. So the period is 2 pi over 15. The horizontal shift is 0 if we use cosine. If we use sine, there's going to be horizontal shift in here also. But, you know, I can't teach this subject in 5 minutes. The only way to teach this subject is to go through each of these variables, A, B, C, and D, and show you the consequences if you change one of them, what it does to the curve. What you need to be able to do is take any sinusoid function and graph it. Or take any graph and come up with the sinusoid function. That's the 2 skills you need when you're dealing with these problems. Okay? Once you have the sinusoid function, then you can tell where that buoy is going to be at any time, just by plugging in x, 15 seconds or 20 seconds or 30 seconds, whatever. But this is just way too complicated to cover in the small amount of period of time we have. I can't even begin to hope to explain it to you. The best I can do is the way I would teach this subject to you from scratch, and it would not be with this problem. Okay? Let me see if I can help you a little bit here, just in the last 5 minutes that we have here. Here. Here's our basic sinusoidal function. Now, you can use sine or cosine. Okay? So, if I had the following, y equals sine x. That means A is 1, B is 1, C is 0, and D is 0. Right? Well, I know how that graph looks. Looks just like this. There's one period of it. It goes out to 2 pi. Okay? And it goes up to 1, and it goes down to minus 1. That's what your basic sine graph looks like. Now, if I make A something other than 1, let's make A 2, what does it do to that graph? That's a vertical stretch factor. It's just like all your transformations. Makes it go up to 2, still goes down through those zeros. See what's happened to the graph? It's been vertically stretched by a factor of 2. So that's what A does, the amplitude, is it sends it up to 2 and down to -2 at the peaks and the bottoms. Okay? Now, let's do, that's a vertical stretch. Let's also add to that a vertical shift plus 3. Okay? When you have a vertical shift, what you do is you move your basic line of symmetry, which is the x-axis right now. That's the horizontal line of symmetry. You move it up 3 units. Okay? I'm going to call this 3 right here. I'm going to draw a new line of symmetry, and I'm going to graph my curve about that line of symmetry. So that red curve would be y equals the sine of x plus 3. Just a vertical shift. Doesn't change the shape, doesn't change the period, doesn't stretch it, doesn't do anything. So when you have a D, that's the first thing you do, is you move that line of symmetry up and then you graph it. With me? Now, if I have both things, if I have an A of 2 and a vertical shift of 3, then this is going to go up to 5, right? In other words, that point's going to be 5, and it's going to go down to 1. So it's going to look something like this. Lower than that. In other words, it takes that red line and vertically stretches it. Now, if you have a B that is not 1, what that's going to do is horizontally stretch it or compress it, based on the fact that the period is equal to 2 pi over b. Remember that. That's a key part of dealing with sinusoid functions. As long as b is 1, you can see the period is 2 pi. And 2 pi is called the natural period of sine or cosine. One complete period goes out 2 pi. So let's make b 2. Okay? In other words, let's make this y equals sine of 2x. Just that. One change only. Changing b to be 2. Well, if b is 2, what's the period? Down lower left, what I've circled. The period is 2 pi over b. If b is 2, what's the period? Pi. Pi. What that means is that if I'm going to graph this green equation, I've got to draw the complete cycle between 0 and pi. And that looks like this. In other words, it compresses it horizontally when you have a b that is greater than 1. If you have a b that is between 0 and 1, it stretches it horizontally. In other words, if b were 1/2, then my period would be 4 pi, and it would go all the way from the origin out to 4 pi for one cycle of the sine function. C is a horizontal shift, just like it would be with a polynomial. Whatever C is, you're going to move the curve left or right by that amount. And that really covers it all. A is the amplitude. B relates to the period horizontally. C relates to a horizontal shift. And D relates to a vertical shift. And that's all we really should cover right now. In other words, you need to understand that before we can actually apply it to word problems. Okay? So that's what you want to be working on, is memorizing the standard general formula. And incidentally, this can be different depending on which school you go to. In some places, that B is inside the parentheses next to the X. That changes a lot. Some schools, they say plus C, which changes the sign on your phase shift, which is the horizontal shift. So this gets more common. The most common one that everybody uses is this one right here. A sine of B, parentheses, X minus C, end parentheses, plus D. That is most likely the one you've been taught. Okay? And your best bet is to try to get a handle on what A, B, C, and D do. In other words, start with your basic formula, y equals sine of x, and start throwing in some A's that aren't 1, see what it does. Throw in B's that are not 1, see what that does. Throw in C's that are not 0, see what that does. And throw in D's that are not 0, and see what that does. Each one of them does something different. And sometimes you have all four of them. In other words, if I write an equation, I'll let you go here in just a second here. I just want to finish this train of thought. Let's say I write an equation like this. I got everything. I got an A, I got a B, I got a C, which is a horizontal shift of pi over 2, and I got a D, which moves everything up 5 units. So these can get very complicated, and when you apply them to real-life problems, you generally have everything. You have an A, a B, a C, and a D, and you have to solve for Y based on those. But anyway, I will let you go, Brandon. And man, what school do you go to? Ralston? You go to Dakota Ridge, and you're taking just Algebra 2, not Algebra 2 Trig. You're kidding. Really? Wow. Teachers should be fired. I mean, I never say that. I hate to say that, but in this case, teacher not know what he's doing, or she, whatever. It's like trying to teach somebody how to ski by dropping them on the expert slope and saying, here, have at it. That's what she's done to you. Yeah. No, of course not, because they've all been dropped on the expert slope and nobody knows how to ski. If you want to teach somebody how to ski, you start them on the beginner slope. And once they master the beginner slope, then you go to the medium slope, and so forth. Well, she's dropped sinusoid functions on you in word problems. That's the hard expert slope even. That's not even the easy expert slope. That's the hard expert slope. So it doesn't surprise me that nobody's following her, because you have to learn the sinusoid function one step at a time. You have to know what A does, what B does, what C does, what D does. You can't just give a person a problem that has all four of them in there and expect them to understand it. But no, I'm not surprised. But Brandon, I will talk to you next time.